Calorimetry, the measurement of energy changes. In calorimetry, energy is transferred from one thing to another. This means that one thing gains energy and another thing loses energy. This often happens with one thing increasing in temperature and another decreasing in temperature. An increase in temperature means the thing has gained energy. A decrease in temperature means the thing has lost energy. So a typical problem might look something like this. A 25.0 gram sample of aluminum at a temperature of 72.8 degrees Celsius is dropped into water in a calorimeter at 25.0 degrees Celsius. The water warms up and the aluminum cools down until their temperatures are equal. The final temperature is 37.6 degrees Celsius. If the specific heat of the aluminum is 0.900 joules per gram degree Celsius, what is the mass of the water that was in the calorimeter? The key to doing calorimetry problems is the idea that we haven't lost any energy in the transfer. In this specific case, the energy the aluminum lost is the same as the energy that the water gained. If this is true, then we can use the energy gained or lost by one of the things to find the energy lost or gained by the other. So the way to attack a problem like this is to separate the two parts of the problem. That is, to look at the thing that lost energy separately from the thing that gained energy. So here we are back at the problem again. We need to identify those two things. That is, we need to be able to say what it is that gains energy and what it is that loses energy. In this case, the water gains energy because its temperature goes up, and the aluminum loses energy because its temperature goes down. We will be able to calculate the energy for one of these two, and we will need to use that energy to find the answer we are looking for in the other one. Which one can we calculate here? In both cases, we have a temperature change. So the formula we use is Q equals grams times delta T times specific heat. Here we have the two formulas written with subscripts indicating that one is for water, but the other is for aluminum. One way to determine which one we can calculate the energy for is to look at the information we are given. To calculate Q, we need to know the grams, the change in temperature, and the specific heat of the substance. In this case, we know these for aluminum, but not for water. So we calculate the energy the aluminum gave off as it cooled. Another way of determining which one we can calculate the energy for is to look at what we are trying to find. In this case, we are looking for the mass of the water. In order to figure this out, we need to know the energy the water absorbed, but we cannot calculate this from the information we are given about the water, so we need to get the energy from the aluminum. So, substituting numbers into the equation for aluminum, we get Q equals 25.0 grams times 72.8 degrees minus 37.6 degrees Celsius, that is the change in temperature, times 0.900 joules per gram per degree Celsius. The difference in temperature is 35.2 degrees. So the equation becomes 25.0 times 35.2 times 0.900 equals 792 joules. So the aluminum has lost 792 joules of energy. Now we can use that energy to find the mass of the water. The equation we have becomes 792 joules, that's the energy the water gained, is equal to x grams times the change in temperature of the water, 37.6 degrees minus 25.0 degrees, times the specific heat of the water, 4.184 joules per gram per degree Celsius. So, rearranging the equation to solve for the grams, we get grams equals 792 joules divided by 12.6 degrees Celsius times 4.184 joules per gram per degree Celsius. And the result is that we get 15 grams of water. So 15.0 grams of water are in the calorimeter. And that's the problem.